Good afternoon, dear students. Yes, good afternoon, Naveshri. Okay, so in the previous class, we were discussing the question paper, right? So we have completed few questions. So let us continue with the same. Yes, so how is your preparations going on? Yes, so there are only few days. Okay, so almost a day left. So are you ready to face the exam, CET exam? Okay. Yes, students. Okay, so let us start. Yes, so let us start with the remaining questions. Okay, so I think we have solved few questions up to 22 questions. Okay, so let us complete it. So excess of PCl5 reacts with concentrated H2SO4, giving you 1. Chlorosulfuric acid, 2. Sulfurous acid, 3. Sulfury chloride, and D. Thionyl chloride. Excess of PCl5 reacts with concentrated H2SO4, giving. Okay. Naveshri has answered it as A. What about others? You can use the chat box for answering. Yes. So it is very important. Okay. So you have to answer it because you are going to write the exam, right? So we should be confident enough and you have to tell the answers. Excess of phosphorus pentachloride reacts with H2SO4, that is concentrated H2SO4, giving you what? So let me see. Okay, so H2SO4, that is your concentrated H2SO4. When it reacts with what? When it reacts with excess of PCl5. So we are taking PCl5 in excess, that is phosphorus pentachloride. What we will get? We will get SO2Cl2 plus 2POCl3 plus 2HCl. Okay, so what we are going to get? We are going to get sulfuryl chloride. Okay, we are going to get what? Sulfuryl chloride. Option number 3. Okay, so let us see here. Yes, option number 3, sulfuryl chloride. Okay, so SO2Cl2. What is the name of this SO2Cl2? It is sulfuryl chloride. So when you concentrated H2SO4, when it reacts with the excess of phosphorus pentachloride, it will give you what? It will give you sulfuryl chloride. Okay, option number D. Got it? Okay, let us go for the next one. An example for a neutral buffer is A, that is 1, ammonium hydroxide and ammonium chloride, 2, acetic acid and sodium acetate, 3, acetic acid and ammonium hydroxide, and 4, citric acid and sodium citrate. Yes, what is the examples of neutral buffer? So neutral buffer, how it is formed? It is formed by mixing weak acid or weak base. Okay, so by mixing weak acid or weak base, we will obtain the neutral buffer. Okay, so which is example of a neutral buffer? You can, so these are the 4 options. Yes, you can use the chat box for answering. Yes. Okay. And Avishri has answered as 2. What about others? Avishri has answered as 2. Others? Yes. Prithviraj, Vamshi Krishna, Vedvati. The students are attending. What is your answer? So neutral buffer, how it is formed? It is produced by mixing weak acid and weak base, right? So here, which is a weak acid and which is the weak base? So among the following, the answer is what? Ammonium hydroxide and acetic acid. Okay, ammonium hydroxide and acetic acid. Right. So this is a weak acid and weak base. Option number 3. Okay, option number 3 is the answer. Okay. Let us go for the next one. So this is from buffer means this is from your equilibrium chapter. Okay. Ionic equilibrium. That is first year chapter. So it comes from there. Okay. Next question. Least energetic conformation of cyclohexane is. So which is the least energetic conformation of cyclohexane? Least energetic conformation of cyclohexane is 1. Chain conformation, 2. Boat conformation, 3. Cis conformation, or 4th EZ conformation. Yes. This is not chain, okay? It is chair. Okay, do this correction. This is a chair, not chain. We don't use any chain conformation, right? When we are writing the conformations of the compounds, okay? So that time we are going to use what? We are either going to use the cis form, cis and trans form, or that is cis conformation, or we are going to form the boat or the chair form. Okay, so this is chair, not chain. It is a chair conformation. Yes? Okay. Vamshi Krishna has answered it as 1. Yes. Okay. So the least energetic conformation of the cyclohexane is what? It is a chair conformation. Okay. Why? Why it is chair? So chair conformation is like this. Okay. So why? It is due to the angle. Okay. So the angle strain is very less. And the diaxial, this also, what interaction? Okay. And when you take a butane structure, the Guachi interaction, okay, it is a in your chair conformation, it is very least energetic and it is the most stable conformation. Okay, so the least energetic conformation of cyclohexane is your chair conformation. Okay, let us go for the next one. Let us see those. Yes. Okay. Option number A, 1. So which of the following is employed in flash tubes in photograph? So in photography, what is in flash tubes, what we use? Argon, neon, krypton, or xenon? So this is from P block elements. Okay, leave it. Which of the following is employed in flash tubes in photograph? Okay, so for your information, it is xenon. Okay, option number 4th one. But this is not there for in your syllabus. Okay, it is option number 4. That is xenon. Okay, let us go for the next one. Conjugate base of H2PO4 minus is. Conjugate base of H2PO4 minus is. Navishri Avedati has answered as 1. Conjugate base of H2PO4 minus is. Vamshi Krishna has answered it as 2. So H2PO4 minus is what? It is a It is a polyatomic atom. Okay. So this is a dihydrogen phosphate. The name is dihydrogen phosphate. So what is its conjugate base? Yes. So the conjugate base of H2PO4 is HPO4 minus 2. Okay. So it is HPO4 minus 2. So it is 1. HPO4 minus 2 again. So it will be HPO4 minus 2. HPO4 minus 2. Okay, so we have to alter that here, not here. Okay, so HPO4 minus 2. So there is a printing mistake. So the answer is HPO4 minus 2. So second, got it? So the conjugate base of your hydrogen dihydrogen phosphate. Okay, it is how you get now here it is H2PO4. Okay, H2PO4. Now, if you remove this proton, okay, if you remove this proton, okay, if you remove a proton from the conjugated acid, what you will get? You will get its conjugate base, right? So removing of this one charge from the conjugated acid, what it will do? It will lower the oxidation state. So it will be PO4, HPO4 minus 2. So when you want to convert the conjugate acid, okay, when you are removing the proton from the conjugate acid and you are converting into a conjugate base, it will be HPO4 minus 2. The answer is HPO4 minus 2. Okay. Let us go for the next one. An alkyl bromide reacts with sodium in the ether, sodium in ether, to form 4,5-diethyl octane. The compound X is, which is a compound X. An alkyl halide X. An alkyl halide X reacts with sodium in ether to form 4,5-diethyl octane. The compound X is. Yes, students, you can use the chat box for answering. So it will react with sodium in ether, that is dry ether, and it forms 4,5-diethyl octane. Octane is, suppose I take CH2 6. Okay, I have to write completely because at 4,5 position you have. So let me write octane. So 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4. So fourth position, ethyl group. At 5 position, ethyl group. So this is 4,5-diethyl octane. CH3, CH3, CH2, CH2, CH, CH2, CH2, CH2. Okay. So what will be the compound X here? What should be the alkyl halide? What you have to take alkyl halide? It should be, yes, use the chat box. So it should be, okay, if I divide this molecule from here, okay, if I divide this molecule from here, so we know that this is a Wurtz reaction. So 2 moles of alkyl halide when it reacts with sodium, okay, in the presence of ether, you will get an higher alkanes, right? So same way, here what we are doing, we are just dividing the molecule into 2. So this is CH3, CH2, 2 times, then CH, C2H5. Okay, or I'll write it more this. So it will be again CH2, CH3. Okay, sorry, CH2, CH2, CH3. So it is CH3, CH2 twice, and here. Okay, so at this position, at the attaching position, I should attach your Br group. Okay, it should be a Br group. So it is option number 4. CH3, CH2 twice CHBr, CH2, Cl. Yes. So option number 4th one. Yes, got it? Got it? So at this attaching position, okay, so I'm going to take your Br. So rest all will remain the same. So this is the alkyl bromide. So this is alkyl bromide which is to be reacted with your sodium in the presence of dry ether to give you 4,5-diethyl octane. Okay. Okay. Which one of the following shows highest magnetic moment? Next question. Which of the following will show the highest magnetic moment? Yes, we have seen how to calculate the magnetic moment. Yes. Which of the following shows highest magnetic moment? Okay, Vamshi Krishna has answered as third one. So Fe plus 2, cobalt plus 2, chromium plus 3, and Ni plus 2. Yes. So how to find? So when chromium is in plus 3 state, okay, it will have 3D0. Then when you have cobalt in plus 2 state, it will be 3D6. Okay, 6 electrons. When Fe will be in its plus 2 state, it is 3D5. And when you have your nickel, nickel in plus 2 is having 3D8. So Fe plus 2. Okay, when you see Fe plus 2, your Fe plus 2 should have 3D5 or 25. No? 25, so it would be 3D5. Yes. Fe is what? Fe is 26. Right. Fe when it loses, so it will be 3D6, 4s2, 26. Right. So 6 plus 2. So if it loses 2, it will be 3D. 1, 2, 3, 4, 5, and 6. Right, it will have 3D6. Now, when it has 3D6, so that time 4 electrons will be unpaired here. Okay, it will be 4 unpaired electron. Cobalt is 28. Okay, so 4s2, so 6 electrons again here. So when you see Fe plus 2, okay, so let us see the answer first. Fe plus 2. Okay, they've given as Fe plus 2. So in Fe plus 2, the highest magnetic moment. So how you calculate? You have to put mu is equals to root of n into n plus 2. So that is 4 into 4 plus 2. So 4 into 6, that is 24. So square root of 24, you have to find out, and that will be the magnetic moment. So like this, you have to calculate the magnetic moment for each case, and then you have to see. Next question. The EMF of the galvanic cell constituted the electrodes Zn plus 2 and Fe plus 2E. So what is the EMF of the cell? So the electrodes, this is given. Okay, EMF of two the cells is given. Zn is 0. Minus 0.76 and Fe plus 2 is minus 0.41. The EMF of a galvanic cell constituted with the electrode Zn plus 2 and Fe plus 2 is. Yes. So we have, how do you calculate? Yes, students. EMF is equals to Yes, EMF of the cell, how to calculate? EMF of the cell is equals to E cathode minus E anode, right? E cathode minus E anode. So, which is the cathode? So, the this will undergo. So, the cathode is your Zn, right? Zn plus 2. So, it is 0.76 minus and minus of minus of minus of uh, minus 0.41 volts. So, minus, so if you take 0.41 minus plus 0.76 volt. So it will be plus 0.35. So this is E cathode minus anode. So oxidation and reduction. Okay. So your reduction is taken place by your Fe. So reduction minus oxidation. So like this. So it is option number 3. Option number 3. Okay, whoever has answered as option number 3, it is the correct answer. Next question, which of the following pairs are correctly matched? Which of the following pairs are correctly matched? So we know that when AgCN is reacted with Rx, you get what? We get RNC. And when we react with KCN, okay, we get CN. We get CN. Okay, let us change this CN. Then Rx plus Na. Rx plus Na will give you your ether. Options are wrong here. So mistakes are there. Okay, so this is wrong. So this is correctly matched. Right. So when Rx plus Na reacts, that is your alkyl halide plus sodium, it gives you what? It gives you what? It gives you alkane. So this is correct. Then when you are this what? Rx plus AgCN reacts with your that is alkyl halide. When it reacts with silver cyanide, you will get isocyanates. What you get? You get isocyanates. So yes, we have to not match the following. We have to just see which is the correct pair. So option number second is a correct pair, and with alkyl halide, when it reacts with sodium, you get alkanes, higher alkanes. But when this what alkyl halides, when they react with KCN, what you get? You get cyanides. You get cyanide. Okay, so this is the answer. So third one is wrong and first one is also wrong. So first and fourth is correct. So second and fourth is correct. Sorry. So option number fourth is the right answer. Okay, let us go for the next one. In a transition series with increase in atomic number, the paramagnetism, what will happen to paramagnetism? It increases, it decreases, first increases to maximum and then decreases, first decreases to minimum and then decreases. Yes. In a transition series with increase in atomic number, the paramagnetism, what happens to paramagnetism? It increases or decreases. What happens? Yes. So when we are So when we are filling the electrons, so what will happen? The first the electrons will be filled into the empty d orbitals, right? So these are first singly occupied. Then what will happen? So because they will singly occupied, therefore the paramagnetism increases. Okay, until all the d electrons are half filled. Then what will happen? Then it will start to pair. Okay, and then again decreases. So what will happen? First it increases and then it decreases. So first it decreases, increases, and then it decreases. Okay. So, so this is the answer. Third one. So first it increases to maximum and then it decreases. Fine. So first what happens as the atomic number increases, the electrons are filled in the d orbitals. So till they are half filled, they are filled. Okay. So it increases. So once the electron, then next electron comes, it will start to pair up. So as it starts to pair up, what will happen to the paramagnetic behavior? It goes on decreases. So first it increases and then it decreases. So option number three. Option number three. Okay, let us go for the next one. Next question. Identify a species which is not a Bronsted acid but a Lewis base. Lewis acid. Identify a species which is not a Bronsted acid but a Lewis acid. Yes. Identify a species which is not a Bronsted acid but a Lewis acid. Yes, students. What do you mean by Bronsted acid and what do you mean by Lewis acid? So boron, we know that boron trifluoride, it is a what? It is a electron deficient compound, right? So it can accept a pair of electron. What is Lewis acid? It donates a pair of electron, right? So your BF3 is not a electron or acceptor. Okay, it will not accept the pair of electron, but it is already electron deficient. So it cannot be a Lewis acid. Okay, so it is not a Bronsted acid, but it is a Lewis acid. So it is a BF3. Okay, it is boron trifluoride. So it is not a Bronsted acid, but it is a Lewis acid. Got it? So it can accept a pair of electrons. So because of that, it is acting as a Lewis acid. Okay. Let us go for the next one. The compound formed when calcium acetate and calcium formate is dry distilled. Compound formed when calcium acetate and calcium formate is dry distilled. Okay, so when calcium formate, when it reacts with your calcium acetate, it produces acetaldehyde. What it produces? It produces acetaldehyde. Okay, so I'll show you the reaction. So this is your calcium acetate. So this is a calcium acetate. So and calcium formate. So this is your calcium formate. So when this is heated, okay, when this is dry, so when this is dry distilled, when this is dry distilled, what is done? What you get is 2CH3CO, CHO, sorry, 2CH3CHO plus 2CaCO3. Okay, so you will get what? You will get a acetaldehyde and you will get a calcium carbonate. So option number 2. Okay, let us go for the next one. D2sp3 hybridization of the atomic orbitals gives you. Okay, so when you have a D2sp3, so D2sp3 is what? So D2sp3. So calculate how many are there. So D2 is 2 plus 1 plus 3. So 3, 4, 5, 6. So wherever you have 6 coordination number, it will show octahedral structure. What it will show? It will show a octahedral structure. So option number 4 is the correct answer. Then the pH of 10 raised to minus 8 molar HCl solution is. Guess what is the pH? pH of 10 raised to minus 8 molar HCl solution is. Navishti has answered it as 2. So log is equal, that is pH is equals to log negative log of H plus ion. So it is minus log of your 10 raised to minus 8 m, right? So it is minus log of. Naveshri has answered it as 3. Okay, let us see then. So HCl is what? So H plus ion, right? It is the 10 raised to minus 8. It's HCl ions. So when you have HCl, okay. So your HCl is what? It is a strong acid. We know that HCl is what? It is a strong acid. So its pH cannot be more than 7. It will be less than, it will be less than 7. Okay, because it is a strong acid. Now here, what will happen? 10 raised to minus 8. 10 raised to minus 8 molar means it is very, very dilute. Right? It is very dilute. So the concentration of H plus will be taken in H2 also as well as in water also. So if I take H plus ion, so H plus ion is equal to 10 raised to minus 7 into water plus 10 raised to minus 8 into HCl. Right? We know this. Now what is H plus ions? H plus ions is equal to 10 raised to minus 7, 1 plus 8. 1 plus 10 raised to minus 7, 1 into 10 raised to minus 1. So I have taken 10 raised to minus 7 common. So we have left with 10 raised to minus 1. So 10 raised to minus 7 is equals to 1.1. So we know that what is pH? What is pH? So pH is equals to minus log of H plus ions, right? Now what is log of H plus ions? So minus log of 10 raised to minus 7 plus of minus log of 1.1. So if you calculate, so log of 10 raised to minus 7 is 7 minus log of 1.1 is 0.04. So pH is will be equal to, it is 6.96. So it is option number 2. Okay, it is option number 2. So the 10 raised to minus 8 molar, the pH of 10 raised to minus 8 molar HCl solution is 6.96. Okay. Which of the following is strongly acidic? So which is the strongly acidic? We know that alcohols, phenols. Okay, phenols are more acidic than alcohols. Okay, in that if you have an electron withdrawing group, then again it is more what it is more strong acidic, right? So which is okay. Your Vedvati and Vamshi Krishna has answered test 3. So which of the following is strongly acidic? Phenol, orthocresol, paranitrophenol, paracresol. Okay, one. So Abu Sufyan has also answered it as 3. Yes, correct. Very good. Paranitrophenol. We know among the alcohol and phenol, phenolic more acidic. Again, if you have electron withdrawing group such as nitro group present on the benzene ring, then again it is a strongly acidic. So option number 3 is the correct answer. Very good. Let us go for the next one. A group of atoms that can function as a ligand only when. A group of atoms can function as a ligand only when. So when the group of atoms can function as a ligand, group of atoms can function as a ligand only when. One, it is small molecule, it has unshared electron pair, it is negatively charged ion, it is positively charged ion. Yes, when the metal, when the ligands can, okay, when these can form as a ligand. Yes, when they have a unshared pair of electrons. So when you have an unshared pair of electrons, so the atoms or a group of atoms can what they can act as what they can act as a ligand. Okay, so yes, 2. Next one, which is not a colligative property. Yes, which is not a colligative property among the following: elevation in boiling point, depression in freezing point, osmotic pressure, lowering of vapor pressure. Which is not the colligative property. All these are relative lowering of vapor pressure. Got it? So it is 4th one. It is called as relative lowering of vapor pressure. Right. Here they have given lowering of vapor pressure. So 4th one. So relative lowering of vapor pressure is not, it is a colligative property, but lowering of vapor pressure is not a colligative property. So option number 4th one is the correct. Yes, Vedvati has answered it. Very good. Acetone and propanol are. So what is acetone and propanol? Acetone and this is your propanol. Okay, what you can see, 1, 2, 3 carbons, hydrogens, 6 and oxygen. Here 1, 2, 3 carbon, oxygen 6 and oxygen 1. So you can see they are having same molecular formula, but the functional groups are different. So option number 1. Okay, yes, Mehak and Vamshi Krishna has answered is correct. Very good. So it is option number 1. Okay, yes. Which of the following is diamagnetic in nature? 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 H2 plus, He2 plus, O2, N2. Mehak and Vamshi Krishna has answered it as 3. So what is diamagnetic? Diamagnetic means what? They do not contain any unpaired electron. Okay. So when we take, so which is diamagnetic in nature? So if you take H2, so H2 is already having 2 electrons. Okay. And in that, H2 plus means again 1. So this is H2 plus. So each hydrogen 1 electron. In that again H2 plus means only 1 electron. Okay. Then He2 plus. Okay. He is 2 electrons. So 1, 2, 1, 2. So it is 3 electrons here. Okay. So this is also 3. So this is also wrong. This is also wrong. Then if I take O2, each oxygen are having 8 electrons. So 1s2, 2s2, 2p4, 5, 6, 7, 8. Okay. So again 1s2, 2s2, 2p4. So leave this. So 4, 4, 8. Then N2, if I consider N2, so here the number of electrons are 6 and 6 is 12. Hmm. So if I take oxygen, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right. So here what you can see, this is also diamagnetic in nature. Okay. Then N2, if I see N2, 1, 2. So a nitrogen is 7. So 1s2, 2s2, 2p, 3, 4, 5, 6, 7. So 5 plus 5, 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so here N2 is diamagnetic in nature. N2. N2 is diamagnetic in nature. Oxygen is paramagnetic in nature. Okay, oxygen is paramagnetic in nature. So this you should feel according to the MOT. Okay, according to the MOT, the electron should be filled and you have to see the electron arrangement. Okay. Next one, 3 grams of urea is dissolved in 45 grams of water. 3 grams of urea is dissolved in 45 grams of water. The relative lowering in vapor pressure is. Yes, how do you calculate it fast? So, how do you calculate? D. Meg has answered it as D. Let us see. So, we have to calculate the number of moles of solute as well as number of moles of the solvent. Right. Now, when we calculate the number of moles of your this what 3 by 60. So first we'll find of solute, number of moles of solute given upon the uh, okay. So this is NB. So 3 grams of urea in 60. Okay, so given mass upon the molecular weight. So this is 60. So calculate how much it will be NB and Na is of water. So given mass of water is 45 and the molecular mass is 18. So calculate and see. So 45 by 18 is 2.5 and 3 by 60 is 0.05. Okay, fine. Now here what you have to do, what is the next step? Now we have to find relative lowering of vapor pressure, that is delta P upon P naught, that is mole fraction of psi will be equal to what? Number of moles of P, right? 0.05 by 0.05 plus 2.5. So how much calculate? So the relative lowering of vapor pressure, it is like this. So if you calculate this, answer just see 0.05 divided by 0.05 plus 2.5. How much you are getting? 0.05. So the answer is coming for me 0.0196. Okay, which is equal to 0.02. So option number 3. Are you getting the same? Option number 3. Yes, option number 3 should be the answer. Option number 3. So what we have done, first we have found the number of moles of solute and solvent, then we have found the relative lowering pressure, which is given by delta P, okay, upon P naught. So what is, that is the number of, that is mole fraction of B. You can calculate by a number of moles of solute upon a total number of moles of solute plus solvent. So by getting that, you will get option number 3. Let us go for the next one. The reagent used to distinguish between acetaldehyde and benzaldehyde is. The reagent used to distinguish between acetaldehyde and benzaldehyde is. Navishri has answered it as 3. Yes, so it is Tollens reagent. So by using Tollens reagent, we can identify which is a acetaldehyde and which is a benzaldehyde. Okay. Yes, Vamshi Krishna has answered it correct. Very good. Let us go for the next one. Metallic luster is due to. Okay, leave this. Go for the next one. Which of the following aqueous solution will exhibit highest boiling point? Which of the following aqueous solution will exhibit highest boiling point? Yes. So you have to calculate what we have to do. We have to calculate, Meg has answered it as 1. So we have to calculate a number of solute particles in the solution. So higher the elevation of boiling point, okay, the more will be the this. So if I take urea, so urea is non-electrolyte. Okay, KNO3, when it splits in water, it will split into K plus N, NO3 minus. Okay, so this is 2. The number of this is 2 here. Then Na2SO4, when it splits in water, it will be Na, 2Na plus SO4 minus 2. So it is 3. The number of ion dissociated will be 3 and C6H6, C6H12O6 is also a non-electrolyte. So answer is 3. So greater the number of solute particles in solution, higher will be the elevation in boiling point. So option number 3. So you have seen that after, how the electrons will be, what do you say? When it dissociates in water, it will dissociate into two ions, KNO3, and this will dissociate into 3. 2Na plus N, SO4 minus 2. So as the number of ions, that is the solute particles are more, okay, after dissociation, so the higher will be the boiling point. So option number 3. Okay, option number D is 3 is the answer. Next question. Which of the following gives amine on heating with amide? So if you heat amide, Okay, if you heat amide, you will get amine. Which will give you that reaction? Which one of the following will give you amines on heating with amide? Mehak has answered it as D. So when you treat it with alcoholic KOH, okay, so if I take RCONH2, when you react it with alcoholic KOH in the presence of Br2, you will get what? You will get isocyanide. You will get isocyanide. Okay. And this imine system, you will get imine system, not isocyanide. You will get imine. This will undergo hydrolysis to give you amine plus HCHO. So with alcoholic KOH. Okay. With alcoholic KOH. Okay. Next question. The number of antibonding electrons present in O2 minus molecular ion is the number of antibonding electron present in O2 minus molecular ion is. Yes. How many electrons, antibonding electrons are present in O2 minus? So if I write the distribution of electrons of O2 minus, so oxygen is 8 electron, one more oxygen 8 electrons, so 16 minus 1, okay, plus 1, it will be 17 electron. So when we fill up the 17 electrons, okay, so 1s2, show here, let me write the here. So so 1s2, 1s2. So here 2 electrons, 4 electrons. Next is 2s2. 2s2, 2 electrons, 2 electrons, 2 electrons. 2 electrons. So 1, 2, 4, 5, 6, 7, 8. Then is 3. So how many electrons are there? 4 electrons. 1, 2, 3, and 4. And another oxygen, 4 electrons. So 1, 2, 3, and 4. So write the MOT. So when the pairing of electron takes place, first the electrons are paired here. So how many in total? 8. So 1, 2, 3, 4, 5, 6, 7, and 8. And one extra electron. So 9. Right? 9 electrons. So what antibonding electrons? Antibonding number of antibonding electrons are how many? They are 1, 2, 3, 4, 5, 6, 7. So 7. How many there? 1, 2, 3, 4, 5, 6, 7. 4, 5. So when you write the number of antibonding electrons here, it is coming 7, but in options it is not given. Okay. So I'll check it once more, just a second. So if the question is like this, okay, on the basis of antibonding, that is molecular orbital theory, what you have to do, you have to fill the electrons, okay. So how the electrons will go to fill? So it is O2 minus. So already oxygen has 8, another oxygen has 8 plus 1 electron. So it is 16 plus 1 is 17 electron. So we have to fill what? 16 electrons, right? So this is sigma 1s, this is sigma star 1s, This is sigma star to sigma 2s, this is sigma star 2s, right? Then this is 2pz. Then you have pi 2px and pi 2py, and this is pi star 2px and pi star 2py, right? So how the electrons will feel, just see. For O2 minus, how much you are getting? Try. Did you write the electrons? Just write the electrons. How much you are getting? Just check.
Seven, ma'am.
Are you getting the 7? So there might be options. Okay, option one of the option is wrong. Okay, so let us go for the next one. The process is spontaneous at a given temperature. If so, when the process will be spontaneous, when the reaction will be spontaneous, the process is spontaneous at the given temperature if delta H is positive and delta S is negative. Okay, then delta H is negative and delta S is positive. Delta H is positive, delta S is positive. Delta H is positive and delta S is equal to 0. Mehak has answered it as B. Yes, so the answer is correct. Delta H is negative and delta S is positive. Okay, so second one. So for this, so for any process to be spontaneous, okay, if delta S is positive and delta H is negative, okay, so this only what will happen, then the Gibbs standard Gibbs energy will be negative. Okay, you know that delta, so we know that delta G is equals to delta H plus T delta S, right? So, so if delta H is equals to delta H plus T delta S is negative, then the reaction will be spontaneous, right? So option B is the correct answer. So delta H is also, delta H is negative and delta S is positive. Okay. Glucose when reduced with HI and red phosphorus gives you. So this is not there. This is there for you in biomolecules. Okay, glucose when you react it with HI, that is hydrogen iodide and red phosphorus. So this is in elucidation of structure of glucose. So what you will get? Yes, you will get not octane. In your glucose, how many carbon atoms are there? It is 6 carbon atoms. So it will give you N-hexane. You will get N-hexane. Okay, so when glucose, when it reacts with HI in the presence of red phosphorus, you will get 6, that is, you will get N-hexanes. This tells you that the glucose structure has 6 carbon atoms. Okay, so N-hexane. Okay, next one. So first one you leave, that is from surface chemistry. Okay, then oils also you leave. Which of the following source and energy flowing based upon? Tell me the 58th one. 58th one. Empirical formula of a compound is CH2 and its molecular mass is 90. The molecular formula of the compound is. So we have solved such problems in our regular class. Okay, so when we are solving this, some basic concepts of chemistry, and empirical formula of a compound is CH2O. Okay. where it went. So if its molecular formula is 18, so empirical formula for compound is CH2O and its molecular for mass is 90. The molecular formula of the compound is. Mehak has answered it as C. What about others? So you have CH2O. So we know that molecular formula is what? Molecular formula can be calculated as N into empirical formula. So N we don't know. N is equals to molecular formula weight upon empirical formula weight. What is molecular formula weight? Molecular formula weight is 90. It is given. Okay, and empirical formula weight is how much? Empirical formula is 12 plus 16 plus 2, 6, 7, 8, 9, 10. So it is 30. Okay, so 30, so it is 3. So molecular formula is 3 into CH2O. So it is 3, 6, 3. So it is C3H6O3. Are you getting the same? So it is C3H6O3. So option number 1. Okay, option number 1. Then hybridized states of carbon in graphite and diamonds are respectively. So what is the hybridization of carbon in graphite and diamond? So it is sp2 and sp3. Okay, so option number 4th one. So 4th one is the answer. So the hybridization state of graphite is sp2. Okay, and in diamond is sp3. So remember this, very important. Yes, Mehak has answered it correct. Very good. So the mass of 112 centimeter cube of NH3 gas at HTP is mass of 112 centimeter cube of NH3 gas at HTP is. Yes, calculate. How will you calculate? So we have to calculate the number of moles. So number of moles is equals to given mass is 112 upon molecule. This is standard is 22.4 is equals to how many moles you are going to get? You are going to get 0.005 moles, right? So we are taking number of moles upon the standard at STP, right? So at standard temperature pressure, the given this is 22.4 liters. So mass can be calculated as 0.005 into what is the mass of your ammonia? It is 17. So mass of NH3 of ammonia is how much? So it is 0.085 grams. So option number 1. Yes, option number 1. Yes, Kamshi Krishna has got it correct. Very good. So like this. Okay, so what we have done, what all we have done now in the steps? Yes, Mehak has also answered it. So first we have calculated a number of moles. How we have calculated number of moles given weight upon the standard temperature pressure, right? At standard temperature pressure, what is the volume? It is 22.4. So you'll get the number of moles. So mass of ammonia can be calculated by number of moles
Not audible, ma'am.
Yes, let us do. Okay. So the number of water molecules present in a drop of water weighing 0.018 gram is. So we know that number of water drops. Okay. So what is the molar mass of water? We know the molar mass is 18 grams. Okay. So we have to calculate a number of water drops in 18 grams of water. So it will be equal to the Avogadro's number, that is 6.022 into 10 raised to 23. So number of water drops present in how many? 0.018 grams will be 0.018 divided by 18 grams into the Avogadro's number, which is 6.022 into 10 raised to 23. So after solving, I will get it as 6.022 into 10 raised to 20. Option number 4. Okay, option number 4th one. Just let me check it. Yes, okay. So, yes, so these were some of the questions. So by this, we have completed solving the question paper. Okay, I hope you have got it. So please, whatever the these are there, okay, important formulas. Okay, so solve everything properly. So please read the questions twice. Okay, so so whatever the important things are there, so please go through that. Okay, so I wish you all the very best for your CET exams. Okay, please do it well. Yes. So thank you. Thank you, dear students. So all the very best for your future. Yes. So we will end the session here. Okay. And thank you.